calculator. So we don't need to do that. We're going to go on and move down to the check your understanding. So you basically have 2 examples and then we'll be done and your homework is already posted. So as soon as we finish, you can go check that out. Okay. Okay, just a second. All right, how quickly do synthetic fabrics such as polyester decay in landfills? A researcher buried polyester strips in the soil for different lengths of time, then dug up the strips and measured the force required to break them. The breaking strength is easy to measure and is a good indicator of decay. Lower strength means that the fabric has decayed. For one part of the study, the researcher buried 10 strips of polyester fabric in well-drained soil in the summer. The strips were randomly assigned to 2 groups. 5 of them were buried for 2 weeks and the other 5 were buried for 16 weeks. Here are the breaking strengths in pounds. Do the data give convincing evidence that polyester decays more in 16 weeks than in 2 weeks? So how do I do this? What do I need to do? Oh, yeah. What's this telling me that I'm going to do?
A significance test.
A significance test and a two sample t-test. Everybody good with that? So we're going to start with our state. So what goes in our state? So we're going to start with our null and our alternative. So what's our null? Yep. What does that mean? Why do we put it equal to 0? If you failed to reject H sub O, what would that mean? There's no difference. That's all that means. There's no difference. All right. What about H sub A? What way? What are we going to do? What is mu1? Yeah, it's going to be your 2 weeks, your group 1. So it's the true mean breaking strength. And go in more detail there, but for the 2 weeks. So then mu2 is going to be for 16 weeks. And you want to make sure you put both true mean breaking strength for polyester fabric buried for 2 weeks and true mean strength for polyester fabric buried for 16 weeks. What else should I put in there? Alpha is, yep. So there's my state. What's my plan? And why is it T, not interval, but test? Because we're doing a significance test. Why is it a T? It's mean. Okay, 2 sample t-test. If conditions are met, those conditions are Random, is it random? Okay, because they were randomly assigned, right? So it's a randomized experiment. Okay. 10%. Do we have to do 10%? Why? We didn't really take a sample, did we? Okay. And then the last thing we're gonna do. Mhm. So does it work? The first sample was 5, and the second sample was 5. I don't know what I'm writing there. Neither were greater than or equal to 30, right? So what do we have to do? Okay, so the first two worked, this one did not. So we need to graph. What are we looking for? Let's see if we can get this right this time. So L1 is 118, 126, 126, 120, 129, 124, 98, 110, 140, 110. Any outliers? They both look pretty normal, right? So we would graph both of those. We have like a short fat one like this. And then we have a longer one. Sorry, my line shouldn't go through the middle, but it's going to. Kind of looks like this.
Sorry,
It's okay.
I'm sure you can.
Okay. And then remember, assume normality. Not as bad.
Not as bad. There's over here behind second base where it was bad, it's perfect.
Good.
And then that's about third base, which is not so bad.
Mhm.
But that's just right there, right from the dugout. And the French drain worked with the water coming off of it. So my assumption is the French drain on the outside is working
Right.
for that part, but then whatever gets right on the field here,
It's just coming straight off.
so tomorrow I'll see if it's dry enough to go out there. I'll have to work on a little bit.
How mushy is it out there?
You won't have to go into the water.
I don't want on the infield.
You
I didn't
can,
know how bad the Cajun stuff was.
uh,
Sorry, guys.
the cage I didn't step in the cage,
Okay.
but I knew the football's gonna stay. The upper field is wet. The big field is wet near the track shed, but down below it's okay.
Pretty nice.
And
Okay.
You can go outside for that, so
Okay.
you got access to it.
Okay. Thank you.
Go indoors, you can.
Perfect. Thank you. All right. So we're going to assume normality because of no outliers or strong skew. So after we plan, we have to do the do part. What are we going to do? Mhm. And how can we do that on our calculator? And what are we doing? Two sample t-tests. And we already have the data, right? In L1, L2. We said greater than, so that's fine. We don't care about food. Let's calculate it and see what happens. I would write down everything you see on this screen. Okay, so if you're going to do it in the calculator, remember you can do it by the formula if you want to. And you did the formula for 2 chapters, okay? But you don't have to. So we're gonna do T equals 0.9889. Our p-value is 0.1857. Our degrees of freedom are 4.6509. You can put 10, whatever, it doesn't matter. X1 or X bar 1 is 123.8. X bar 2 is 116.4. S sub X of 1 is 4.6043. And of 2 is 16.0873. And there's your N1 was 5 and N2 was 5. The biggest thing that we need out of here is our p-value. So that in the conclude, we can test our p-value against alpha. Our p-value was 0.1857. Alpha was 0.05. Greater than means fail to reject. And that means and just so it's on record that the true mean breaking strength of polyester fabric that is buried for 2 weeks is greater than the true mean breaking strength for polyester fabric that is buried for 16 weeks. Everybody good? Well, one more example and we'll be done. And I'm sorry I was interrupted. We would have been done quicker. No worries. Last one, comparing tires and comparing workers. In each of the following settings, decide whether you should use a paired T procedures or a two sample T procedure for performance inference or to perform inference, and explain your choice. So the first one is test the wear characteristics of two tire brands A and B. One brand A tire is mounted on one side of each part in the rear, while a brand B tire is mounted on the other side. Which side gets which brand is determined by flipping a coin. All right, and then B says, can listening to music while working increase productivity? 20 factory workers agree to take part in a study to investigate this question. Researchers randomly assign 10 workers to do a repetitive task while listening to music and the other 10 workers to do the task in silence. So we need to figure out which one is which. What is the difference between a paired T and a two sample procedure?
Wouldn't a paired T be when like the one about the amusement park rides from our last test?
But how? What do you mean?
I was just asking if that's what a paired T procedure is.
Yeah, it's pretty much the same. But what's the difference between a paired T and a two sample?
For the paired T, it's asking like which one was visited more or done more, but then the two sample is asking if there's like a bigger difference.
Yeah, I get where you're coming. The easiest way that I can tell you, you guys remember matched pairs? You guys remember that a long time ago? What was matched pairs? So anybody remember matched pairs? Sorry. Matched pairs means that you get both treatments. Okay. So a person might take it randomly compared to everybody else, but they get both treatments. So the one that I can remember was drinking juice, vitamin C, and taking aspirin or something like that. They were taking something. So they both did both of them, but they had to see one of them did juice and then one of them did no juice. But then they swapped, and then they did it again. So everybody in the experiment did every treatment. So it wasn't a placebo and a pill. It was they did the treatments together. They just randomized how they got it. So maybe group A drank orange juice in the beginning and took their aspirin after they drank the orange juice, and the other set took the aspirin first and then drank orange juice, but they both got both treatments. Okay. So this first one is a paired T. And again, it's like matched pairs. And why is it like that? Is because A was mounted to one side and B was mounted to the other side. So they're on the same car. And then determining which side is flipped by a coin. So the car gets both A and B, but it just depends on what side. So they get 2 treatments. And those were tire A and tire B. And then they random assign to rear sides. So in part B, they split it up. 10 workers get listening to music and 10 get silence. So they don't get both treatments. So just think about paired or matched as being both treatments, okay? So this one would be a 2 sample T. Because there are 2 distinct groups of workers. In a randomized experiment. You can also think of it this way. The random assignment comes in the beginning to split the groups for a 2 sample. And paired T's, the random assignment comes from which treatment to get. Okay, so it's a little bit different. All right, so you're going to be doing that in the end. Now, I told you guys at the bottom, there were these little things right here, and we would be doing those later. Make sure that you watch that, get your notes, not right now, but tomorrow, get your notes out. And in fact, they're already posted right now. You can get your notes out and check that out. The alternate example that goes with this, like it's going to look just like this, is the one that's labeled testing with distractions, page 650. Okay, so you'll see that label at the top. So if you want to go back and reference where those came from, your notes tell you where they come from. All right, so you have a homework assignment for today. It is already posted, and then tomorrow's stuff is also already posted if you want to jump ahead. All right. I'm going to stop sharing, stop recording.